Thank you, Daniel. Yeah, thank you for having me. Today I'm going to try to avoid talking about IMS. I started in 2004 at Fraunhofer Focus, and IMS was one of the first topics for me, and nobody knew what it was. And yeah, it was a difficult ride, and a lot of people, really expected that Web 2.0 and Facebook and things like that would happen on top of IMS. So now it sounds really ridiculous. But back then, a lot of people really thought that IMS is going to be the future of the routers in the internet, and this is how the operators would rule the world and all of that. Well, for me, it was always about the nice architecture and about finding a sort of a carrier-grade good architecture for doing voice over IP, a standardized way into it, and not trying to rediscover the wheel every time, right? Everyone in the C++ router community was calling it a load balancer, and I was calling it an ICSCF, or session border controller, and I was saying it's a proxy CSCF. So we were talking about the same things, but anyway, here we are today. After in 2008, 2009, I kind of abandoned a little bit the open source IMS project. Until now, I guess. And many thanks for Daniel and Karsten and Jason and others that took the modules and they made sure that they are working very well in Kamailio. They did a lot of changes to the modules so that they removed a lot of my initial craziness going in there, and they reminded me that, hey, we have a script. You don't have to do everything in C. We can do it in the script, and then it's more flexible. You can do other things if you don't like some things without recompiling and so on. But anyway, just fast forwarding. A few weeks ago, I had this great sort of experience, after more than 10 years ago, starting with IMS, that I took my private personal phone and I plugged it into to our Evolve packet core that we're developing and to Kamailio IMS, and I could make a call. And I'm not talking about any app, I'm talking about the native dialer, and that's what I want to talk today about. Voice over LTE, so voice over IP for mobile phones, and what's built what is built in directly in the smartphones today. So I would start by just introducing a little bit LTE. Well, 487 operators out there that launched LTE, so quite a lot. More than 50%, or well, more than 49%. About half of the population is covered by LTE today. And what's interesting about this is that there is no circuit switch in LTE. So you don't have anymore the legacy there for telephony. So you have to do something, because you cannot just ignore it and say, well, we have 2G and 3G to make calls, and then LTE is like Wi-Fi for when you need really fast connectivity. So that's what many operators have deployed already, voice over LTE, but you see there's a huge still difference between them. 487 operators that have LTE, and just 65 of them have voice over LTE. The others are doing circuit switch fallback probably. So every time you make a call, bye-bye LTE, bye-bye nice speeds, bye-bye super nice latency, you're back to the Stone Age. So what is there in the phone already, but sometimes not activated and so on, it's a SIP client, which, well, it's called IMS client or voice over LTE client and so on. And yeah, I think that's a very interesting, part of the market that Kamailio should go after and tap into. LTE, it's a prime example, but by the way, 3G is the same thing. It should have happened. This transition to voice over, packet switch and SIP and RTP and so on should have happened in 3G. It didn't happen, but still, it's a good target. What's also still very interesting is voice over Wi-Fi. So you probably, heard that voice over Wi-Fi has been launched by a few operators, and I really hope that it's going to be launched here in Berlin, because I have no calls at home. I have perfect Wi-Fi, but no 2G, 3G, LTE, nothing. So I really hope that's going to be launched also here, because it's just, the same thing. You have LT, which is an all-IP. It's just providing all-IP with QoS services. So it's not that different from Wi-Fi. The same thing that you're doing on Wi-Fi, you can also do. The same thing that you're doing in LT, you can also do on Wi-Fi. So you'd say, well, but why? I mean, we have an app that does SIP and VoIP, and why do you need this? Well, let me try to use some, metrics a little bit to try to sway a little bit to see that this is actually a good idea. First of all, we have very fast call setup, so this is a big advantage in LT networks when you're registering to the SIP servers and so on. Basically, the standard says that a dedicated bearer for your signaling should be established with very low packet loss and very high priority. So all the signaling that goes for voice over LTE gets the best treatment. So it's not going to be, sort of, oh yeah, we might lose some messages or anything like that. The second reason is battery consumption. The native dialer that we're talking about, that one is sometimes even below the operating system. It's in the baseband, if you want. Yeah? So it's not necessarily provided by the guys that do the, let's put the phone together, put a nice logo on the back and ship it. But it's done by the guys that do the LTE chip or chipset, that baseband. So you can already see that if you're doing it at that level, you can take full advantage of the hardware accelerators for the codecs and all of that. So you can have great battery life and also low latency also for the voice. Voice quality, I mean, yeah, probably not so much, but operators, of course, they want to push onto you, the big operators, that this is HD voice, finally, it's better than 3G. But when you compare it with other Skype, and I don't know, I'm pretty happy with Hangouts, so yeah, that's not a very good argument. But still, then availability, yeah, it's always on your phone. It's actually a regulatory thing. You're not allowed to provide in US, I don't know if it's still true, but it was that you were not allowed to provide LTE data-only services if you didn't have telephony services. So if you cannot reach the 911, no data for you. Yeah, so the LTE was not working if you didn't have an overlapping 2G and 3G to support calls. So it's always in the phone, it's always available. You don't need to install any app or anything like that. You don't, it's part of the basic service, the mandatory service that has to be provided. Yeah, integration with the contact book and so on, your contacts and so on. Well, any app, almost any app can do that today. So in the end, it's all about the Wi-Fi calling and the voice over LTE calling, so that we can get some good quality. And studies seem to confirm this, that actually voice over LTE does pretty well. For example, call setup versus time to ring. Voice over LTE seems to be on front. And well, it's not surprising because obviously the packets get prioritized over the network, right? And also they are, if they are, sometimes maybe outside of the main operating systems, then they don't have to deal with events that happen in there, but they can sidestep, and it's a big advantage if you are running that client where you also run your IP connectivity and the modem software and so on. So very low latency for setting it up. Let's go next to message delivery time, SMS over IP. So delivering SMSs over SIP seems to be the fastest. Again, signaling is being prioritized. There is a better one, RCS with MSRP, but that I'm sort of, okay, they're using MSRP, so all right. There is that part that puts it in front, but otherwise, I think that's doing pretty well. And Also important is the radio resource usage. You see, actually, voice over LT uses much less. It's part because you have codecs with low bitrate and very good performance. But it's also because the resources, the radio resources, are pre-allocated. And then you're less wasteful on the radio interface. If you know that every few milliseconds there's going to be a packet this big and it has to be sent, and you don't have to signal every, and say, oh, I have one more packet. I have, or send it sort of on the random access. But if it's pre-scheduled, then you can save there on the radio resources. And well, last, maybe not so important, service success rates. Well, maybe the study was done by telecom-centric guys. Obviously, here, voice over Wi-Fi, voice over LTE, SMS over IP, they're close to 100%. So yeah, but I don't know how they were testing Skype and so on. So that's why, yeah, well, take them with a grain of salt. But still, it seems that they're coming up in front in some areas. And just to summarize a little bit, also the user seems to be happy about it because you have just the typical AMR wideband codec, 13 kbps, and a good MOS score for that. So what's behind it to do it? And like I said, I don't want to talk about IMS now. So there is a lot of IMS, but let's ignore that for a moment, because if you go after that, it's just going to be thousands over thousands over thousands of pages written by 3GPP that you drive yourself crazy with that. Fortunately, for this to happen, this standard happened in GSMA, like the IR92, which tells you just what you need. So don't go for the whole thing. Fixed mobile convergence, all the craziness. No. If you want to do voice over LTE, that's what you need to watch for, which then points you back to 3GPP, but at least they tell you just what you need. Yeah? So they make it a little bit smaller. So you have requirements for IMS. These parts in there, the CSCFs you see there, application servers and so on. You have requirements for the Evolved Packet Core. That's what runs your core network for the mobile domain. And then, of course, you also have some requirements for the radio side. You can run it over LTE. You can still run it over 3G and so on. Probably shouldn't try to run it over 2G because it's simply not built for that. And, well, again, 3GPP, you see, they're missing Wi-Fi in here. Where's Wi-Fi? It still works over Wi-Fi, but yeah, they don't like to put it everywhere. So IMS requirements, EPC requirements, radio resource requirements, supplementary services, also very interesting. Yeah. You have to note that IMS is not sort of, oh, we're going to take this circuit switch voice and we're going to replace it entirely. No, IMS just provides you the basic platform. And after so much work, then you realize you need much more work to actually get to the full service. So all the supplementary services, they're additional to that, MMTEL or RCS and so on. But let's keep it just to MMTEL for now, because you don't need the full blown thing to just do the standard voice over LTE calls. And of course, you also have to deal a little bit with the mobile phones. But that seems to be a little bit simplified now, as we have a demo outside with a stock iPhone, and we also have stock Samsung Galaxy phones, and they work with Kamailio. So how have we done this? Well, you can see there we use for the CSCFs components from Kamailio. Had to put my logo there with OpenIMS Core, right? But I have to say that all our investments now are on the Kamailio platform. We are not doing anything on the old C++ router platform that we had for the project, but we are trying to concentrate together with the other guys on the Kamailio platform. And then the OpenEPC project, we use the functional elements from there. That's what Current Dynamics mainly does. That's our key focus to create that seamless IP connectivity platform for 2G, 3G, LTE, and Wi-Fi. Yeah, so if you want to see all the interfaces with the names on that, there is a slide for that also. You can see the orange ones are the ones provided by Kamailio. I also list Kamailio here for the application servers, for supplementary services, for telephony application services, yeah, for service call continuity, and so on. Or we heard this morning quite a lot about online charging, so that can also be served there. So what have we done? Well, not much really. We had to use standard domains. We used some standard SIM cards, not even sort of 4 IMS SIM cards, but standard 3G, LTE SIM cards. And because of that, we just had to use the proper domain names as 3GPP specifies them. So they have a special format for that with 3gppnetwork.org and all of that. Second of all, we had to switch everything to TCP. Can't believe how big these messages get. We have full traces outside, so you can look at them and even live as they are produced by the phones. And the messages get pretty big. Then for authentication, we had to turn this off because the IPsec implementation is, not fully there. Initially, what I did in the OpenIMS core project was just a proof of a concept that every time you had a new phone coming in, there was a simple bash script that instructed the kernel to decode something. But that's probably not what you want to do when you have hundreds or thousands of phones and attach and all of that. You want to do a proper management of the security association. So that's still work to be done. We had to turn it off because if you turn on authentication, then the messages start to come encrypted, and if you cannot deal with them, you cannot talk to the phones. So at the moment, we're just using the EPC security. We do authenticate the phone when it attaches to the network, and then we can use that information saying, okay, if the phone attached and we gave it this IP address, from this IP address, it's okay to register this identity. So there is still security in there. Is just not the full one yet. For voice calls and so on, many thanks to Daniel, we dragged him, to our offices for a day. It's great to have to work in the same city as he does. So we dragged him, and many thanks to him, we fixed lots and lots of bugs that we encountered in there, and we could do all of that. This is just because probably these particular phones, they do something special, and they're going into some things that have not been tried maybe before. So that's why we had to fix those. We still have to discuss in the community a little bit about what are we going to check in this proxy CSCF security gateway. What are we going to check about the message? It seems that now we're checking a little bit about the context, but I'm more towards the vias and the origin IP address of the message, and for proper security, we have to sort that out a little bit. But another important thing was that we had to enable this RX diameter interface. And that's mandatory because stock devices will try to allocate the QoS resources, and if they fail to do that, they will refuse to let the call continue. So that's, if you want to do the full voice over LTE call with stock phones, that's mandatory, unfortunately. And for messaging, we're using the SMS ops module, but it's still pretty hard with the phones because the SMS just comes directly as encoded even on the legacy 2G and 3G. So we still have to do a little bit of work in there to properly decode and change it and so on. You cannot just deliver it to the other side. You have to modify a little bit the 3GPP payload. So on the other side, in the Evolve packet core, well, we just had to set up a special APN because typically this the whole voice over LTE goes over a different connection than your standard internet breakout. It makes sense because Maybe you want to secure your network differently. Maybe you want to run IPv6 on for voice and IPv4 for your run-of-the-mill internet breakout, things like that. So anyway, we just had to make sure that we are properly setting up the APNs and that we are setting the proper bits and bytes in there in the messages to tell to the phones, this is an IMS ready network, and you can send that register. So, interestingly, the hardest part was really to convince the phone to send the first register message. After that, it was pretty straightforward, pretty easy, and nothing so special. Setting up the QoS, of course, the protocol configuration options was also important, because this way we can give to the phone the address of the Kamailio, the first proxy CSEF, that security gateway for the user to the network interface. And yeah, just had to make sure that we're also deploying a PCRF for the QoS, and yeah, after that, well, our HSS is dual IMS and EPC, so it was pretty straightforward, and it was working out. Just to highlight a little bit the QoS, well, sorry that you cannot see properly the colors. You need these components in here talking to that security gateway that derives from SDP directly what QoS is needed for that call. And what's pretty interesting about it is that you're doing it once for calls, for audio calls, and then you're just reusing it for video calls. Or at one point, we had a customer that was asking us, can we do a sort of TCP connection establishment with an invite? And the same code that we used for that in the SDP, just describing the TCP connection, describing that audio call works also for a TCP connection. So it's the same thing. You're telling to the PCRF, what do you need? The PCRF is going to talk to all the components in here. It's going to be a sort of a propagation of dedicated bearers and the QoS rules, and it gets all the way to the cells. The cells even, sort of, well, core network components talk to the mobile phones also, so also the uplink is in sync. And when everything is established, then finally the iPhone starts to ring on the other side, and then you can answer and you can have the whole call. So these are the devices that we used, really standard. I did observe that if you're using something older than iOS 9.3.1, yeah, you're having a little bit of trouble with that. We used with equal success USIM only, as well as iSIM SIM cards, so the IMS specific SIM cards, but we just USIM, it just works the same. The iPhone is capable of deriving the identities. The Galaxy S7 had a bit of trouble with that. We're not entirely sure about this, but our guys still think that they can maybe convince the Samsung to work with USIM only, but so far we failed. And like I said, dedicated bearer is mandatory. And we also listed the modem. I think this is interesting because we believe that that's where this functionality resides, not necessarily in iOS. So, and we found a lot of similarities between the messages that the iPhone sends and the Samsung, the Galaxy sends. It could be just because the operators are quite strict about the profiles in the messages, and then they're forcing all the handset manufacturers to send sort of similar things, but we're guessing that the implementations there are not so different. So the good news is that you don't have to deal with thousands of different crazy phones each doing its own thing, but it seems that at least the voice over LTE devices are a little bit more uniform. So if you look in the signaling, the user agent is different, but otherwise all the headers sort of seem like they were written by the same developers, to be honest. Things, seem really, really similar. This is a demo setup that we have outside. Yeah, we virtualized the entire EPC. It doesn't need such a big system, but yeah, that's what we had free this week. I think in the past years we had maybe some Raspberry Pis and things like that, so that would also work. But we just use a proper one. We used a standard LTE E-Node B, so a standard base station, and we plugged in the radio to a Faraday cage, just to isolate the radio environment so that we wouldn't upset the regular operators, running this without a license. So we isolate everything. You cannot see it from outside. Inside the box, you cannot see the outside networks. So the phones are completely isolated, and you can have the full calls with the native dialers, unmodified stock. So yeah. So I have to mention, though, that the phones have been activated for this. So we have not played with iPhone profiles and so on. So the phones have been activated by T-Mobile in our case for use with voice over LTE, and we were not messing with that. So that's another difficulty that you have to go over, unfortunately. Convincing the phone to use voice over LTE on a network that maybe has not been certified by Apple or Samsung or something like that. Right, so that's it in a nutshell. On a roadmap, what are we looking at? Well, for the CSEFs, obviously we're using Kamailio, and we want to continue to use Kamailio because we have great performance, we have this scalability, and we have also the flexibility that the routing script gives you. We still need the supplementary services listed there also additionally. So all the other things around, or service call continuity. If you run out of LTE, what do? You're going to switch to a circuit switch call, but we want the call to continue. So there is an application server in there to make that happen. Security, I mentioned before, that still has to be done. TLS probably works, but we also want to do the IPsec because that would allow us to use also just UDP. And that's in Kamailio. In OpenEPC, we're looking at IMS centralized services, so 2G and 3G, circuit switch voices, translating directly to SIP and RTP without having SS7 or anything strange like that in between, and having the same Kamailio core network for telephony serving both circuit switch and packet switch voice. Single radio voice call continuity, as said before, circuit switch fallback. Voice over Wi-Fi, I think this is really a nice feature to have, because again, you're going to use the same native dialer, the same thing that is built into your phone every time you connect to Wi-Fi. So yeah, don't need an app, don't need anything like that. You can directly use that integrated thing. Of course, it doesn't have nice features. It just calls. Good luck trying to find the video call button, but yeah. And otherwise, yeah, we're looking to support and to try out more phones to see how we can configure them so that you could, push profiles to the phones and to enable voice over LTE and voice over Wi-Fi without requiring to be a big operator and so on. All right, so that's it in a nutshell. For your reference, I have created a more detailed list of things that we would like to work on next. And if we missed something, or if you can help with this, let us know. Myself, Karsten, I think Jason, also from Smilecoms, and other guys that are working on IMS would be, really welcoming your help in this work.
Okay, thank you. And now questions.
Well, I'm sure you don't intend it, but I feel like you're taunting me because
Why?
That's enough complexity as it is. But I mean, I can never use it because you can't. You're not in the club. You've got no way to access. You've got no way to you can't even get started. So I accept and understand that it's technically superior, but basically, it's I don't know who it's for, but it's not for the majority of us, is it?
Well, why not? There are many that claim that do open source also the EPC and so on, but you're right in that sense that I don't know if there is somebody that truly does it as open source or is free and so on.
No, but I can't get access into the networks. I can't get the spectrum licenses. I can't get the necessary relationship with somebody who has.
Yeah, but you see, there was the point. well, but here's the phone, and there is Wi-Fi.
But also the dangerous demo is more or less like similar setup from the Evo, right? So now you can buy it for 2,000 and have your LT sell at home, and then
Yeah.
not in South Africa, right? It's everything illegal there.
It's also illegal,
So-
but we don't worry about that so much. Customer service.
So you're absolutely right that if we're talking purely about LTE, there is a problem there with the spectrum, obviously, right? Because the big operators have basically bought it, and yeah. But on the other side, you can be an MVNO and use the LTE network from an MNO. And I think it's a great thing still. Why not? Why not? You're using the access network and you're deploying your own SIM cards. You're giving your own devices or standard devices to your users. And as an MVNO, I don't see why you wouldn't be able to use voice over LTE and voice over Wi-Fi.
I don't want to hog it, but I can
So-
spend a year then trying to negotiate with somebody about that, or I can spend a year
Yeah.
implementing the best over-the-top client I can.
Look, I don't work for them. So,
Okay.
you know, I agree with that. But yeah, it's not, unfortunately, not something for me to solve.
Yeah, I have a question. You said something about the application server that
Yeah.
was a little quick for me. The following scenario: I have a 4G, a good coverage. I have a call over voice over LTE, and then my coverage is gone. What will happen? Can you comment on that?
Yeah. Sure. Can I have maybe my slide? Thank you. So, yeah, you're losing basically the packet switch voice. That's how I would call it, right? Well, in that case, because it's in the baseband, the implementation. On the mobile device, it's not that hard to coordinate between the SIP client and the legacy client to do the handover and say, oh, okay, now you use your other codec, and here's the data from the microphone, and give me the data to the speaker. So that part is relatively easy. The more complex part is here, because we're switching from handling the call in here, you know, coming as IP packets over here, to handling a call here. And this MSC is a component that typically was talking here, you know, SS7 and things like that. The MSC that we have is an IMS centralized services one. And there is this I2 interface very nicely. So what happens is that when you move into a 2G or a 3G cell, basically this MSC sends another SIP register in here saying, oh yeah, I have the user and I'm going to simulate the SIP user agent. So in the end, it's just a handover that this continuity server, if you want, helps you a little bit to handle. If you take the full standard, actually, this is way more complex that we need to make it if we have this SIP user agent in here. So ourselves, we're going to take the short path and just basically do a handover between two SIP user endpoints.
Okay, one last question, because we can talk about this for ages.
Hi, I asked you a lot more questions, so here's another one. From my understanding, there's some kind of server and client verification mechanisms through certificates that are done with phones. How did you get around them if you had to, and if you didn't have to, when do those come into play?
Well, I haven't activated. I mean, you know, so the profiles on the phones. Sorry, I'm going to say this. I'm going to put it out there. I'm a T-Mobile customer, so the profiles on the phone have been set by T-Mobile, and it seems that T-Mobile accepts this sort of affair. So maybe we just got lucky, but I think we didn't get lucky because actually the Evolve Packet Core is supposed to secure anyway the communication, so it's not like it's in the open or anything like that. So you have the two options. Either you do TLS, and in that case, the phone should verify the certificate of the proxy CSCF. So you should have one that the phone, you know, can do the whole chain thing and verify if that works. And even if that happens, you have to do authentication with a SIM card. It seems that still, today, it's okay if you don't do that, because you cannot come from outside and access that IMS network. So the only way into the operator's own IMS infrastructure is through the Evolve packet core, which would secure the attachment to the network, and we do basically the layer 3 security, so that everything that goes between the mobile device and the IMS server would be secured.
Okay, thank you. A bit of a long.
Thank you.